Hi, Luke here from Technicamps with the last session in the Introduction to Programming for Teachers course, all based in Python and being run by Technicamps. This final session is quite a long one, so there are points where you might want to pause the video, go away, recap on the stuff that's been covered, and then continue. And the session's all going to be about something called lists. And you've got a nice picture here of kind of train carriages, which kind of are actually quite a good analogy for lists. So the contents of today's session is going to be basic properties of lists, list operations, common list algorithms, using lists with functions, and then finally tables. So the motivation of where lists come from is a computer program often needs to store a sequence of values and then process them in some way. For example, if you had the sequence of values on the right-hand side, so 32, 54, 67.5, 29, 35, 80, 115, 44.5, 165, if I wanted to store all of that, and I just did it with variables, I'm going to need lots and lots of individual variables. I'm going to have an input 1, an input 2, an input 3, 4, 5, 6, 7, 8, 9, 10, right? And let's say that I had lots and lots and lots of inputs, and I had to keep track of them all, and all of a sudden I've got a huge number of variables, and I'm having to remember what each of them are called, even if they're indexed in a nice way like this. So instead of using huge numbers of different variables, we use something called a list. And what a list does is it just collects sequences of values. Okay, so to create a list, we use the square bracket notation. So we specify a list variable with square brackets. We give the list a name, a variable name, so for example, more values, and then square brackets will create the list. And you can have an empty list, that is a list with nothing in it, or you can have a list with some initial values, which are all comma separated. So more values equals open square bracket, close square bracket creates an empty list, and then values equals open square bracket, 32, 54, 67, 29, 35, 80, 115, close square bracket, creates a list with some initial values in it. Okay, just like when we accessed items from strings, you can access elements from a list using the square brackets in this form. So call the name of the list, square brackets, and the index of the item you want to talk about, and then you could maybe overwrite it. Alternatively, the second line is assign the value of the ith entry of the list values to the variable element. Okay, so this is kind of the form maybe we've seen before, where we take a specific value from a string, and this time instead of taking it from a string, we're taking it from a list. Or accessing rather than taking. Accessing is a better word. Okay, accessing list elements. So a list is a sequence of elements, each of which has an integer position or index. To access a list element, you specify which index you want to use. That is done with the subscript operator in the same way that you accessed individual characters in a string. So if you want to print the element at index 5 of the list values, you'd have print values 5. You can also replace elements in the list. So if you wanted to replace the element at index 5 of the list values, you'd have values square bracket 5 equals, and then you're updating that value with the value 87. Okay. Just like with strings, we index from 0, so we have our 0th entry, our 1th entry, our 2th entry, 3, 4, 5, 6, 7, 8, 9. Okay. So part 1 here, we create a list. This list has 10 items, so we say values equals open square bracket to indicate we're using a list, and then giving it some initial values. So our 0 index is 32, our 1 index is 54, our 2 index is 67.5, and so on. And then we close the bracket, okay, indicating the end of the list. And then let's say we want to access the the element at position 5 and update it, or index 5 and update it. So we'd access the index at position 5, so 0, 1, 2, 3, 4, 5, which is 80, and we'd update it with the value 87. And you can see in part 2 here that we've accessed and updated the value in index 5 from 80 to 87. Okay, both lists and strings are sequences, and the square bracket operator can be used to access an element in any sequence. So we've seen in strings, if you wanted to access some of the elements or in a string, you could use the square brackets operator. Lists are also sequences, so you can use the square brackets operator to access elements from those. There are two differences between lists and strings. Lists can hold values of any type, whereas strings are sequences of characters. Remember that if you take an input, for example, and you take in the input the numerical symbol for the value 5 as a string, that is different to the integer value 5. Okay, so strings are sequences of characters, whereas lists can hold strings, they can hold lists, they can hold integers and floats, complex numbers. So lists can hold values of any type, whereas a string is limited to only being able to hold sequences of characters. Moreover, strings are immutable. You cannot change the characters in a sequence. So if you input a string, you cannot take the 6th entry of that string and change it to another value. They are immutable. The characters in that sequence are immutable. But a list is mutable. As you see here, we can just change the value in the index 5 position to another value. Okay. So lists can hold any type, whereas strings can only hold characters. Strings are immutable. You can't change the characters in the sequence, whereas lists are mutable. You can change the characters or the elements in the sequence. Okay, so this is what I've just scrolled back to, but lists are mutable. As you saw in the previous example, the result of the operation values 5 equals 87 updates the value at index 5 with the value 87. Okay, showing that they are mutable. You can update the values in a list. As with strings, list indexes start from 0, very important. That is, the legal elements for the list are values square bracket 0 is the first element, values square bracket 1 is the second element, values square bracket 2 is the third element, and so on. Okay, remembering that we go up to the length of the list minus 1. So if the list has 10 elements, the 10th element is at index 9 because we're starting counting from 0. Okay, you have to be careful with that your index stays within the valid range. Okay, you need to really be careful. Probably the most common error, I would think, when using lists is trying to access something that's out of range, accessing a index whose range is beyond that of the actual list. If you attempt to do that, you get something called an out of range error or a bounds error. When this happens, it occurs at runtime and causes a runtime exception. The most common out of bounds error that people have is trying to find the 10th element or the last element of a list, and they go, the list has 10 elements in it, so I'm going to access values 10. That doesn't exist. There is no the index 10 is would be the 11th item in the list, because we start indexing from 0. So actually, if we want the 10th element, we say values 9. Okay. So again, this idea of indexing from 0, going up to the length of the list minus 1, is quite important. One really helpful tool in determining, and making sure that we don't go outside our bounds is using the length function or the len function. That gives us the length of the list back, the number of elements in the list. So num elements here equals len values is going to take the list values and return how many elements are in the list. In our example, it would be 10. There are 10 elements in the list. The length of the list is 10. The following code ensures that you only access the list when the index variable I is within the legal bounds. So we're ensuring that our index variable is greater than or equal to 0, because we don't have necessarily a minus 1th element from our values list. And the index is less than the length of the list, because the length of the list because we start indexing from 1, the last item that we can actually access is the length of the list minus 1. So strictly less than the length of the list will keep us within our bounds. Okay, there are two distinct uses of square brackets. When the square brackets immediately follow a variable name, they are treated as the subscript operator. So this is us accessing a value from a list, or a sequence even, necessarily, because we could be talking about maybe a string here. When the square brackets do not immediately follow the variable name, they create a list. Okay, so accessing something from a sequence versus creating a list. Okay, there is a key difference between the two. So we've got our list of data, our list of values of some sort, and maybe we want to look at the values in our list. Maybe we need to, count the number of first-class grades that we've got, or students who live within 1 mile, or whose name is Jeff, right? To do that, we can kind of visit the list in either two ways. We can either loop over the index values and then look up each element. So we'd have an I counter going, okay, look at index 0, look at index 1, look at whatever's in index 2, look at whatever's in index 3, and so on. Or you can actually loop over the elements themselves. Okay, so kind of skipping out the idea of looping over the index values. Okay, so given the values list that contains 10 elements that we've looked at in all our examples, we will want to set up a variable, typically we call it I, and we will index that variable, we will increment that variable from 0 all the way up to 9. So for I in range 10, so I is going to go 0, 1, 2, 3, 4, 5, all the way up to 9. Print the I value, so it's going to print 0, then it's going to print 1, then it's going to print 2, then it's going to print 3, all the way up to 9, and the element at that index. So it's going to print 0 and the element at position 0. It's going to print 1 and the element at position 1. It's going to print 2 and the element at position 2, and so on, all the way up to 9 and the element at index 9. Okay. A slightly better way of writing that is, instead of having this floating like 10, this number just hanging around that we don't really know what it means or what it's referencing, we actually use our len values here to give us a better indication. Okay. So for I in range len values, so if the length, we work out the length of the list and we go from 0 up to the length of the list minus 1, and then again we just do the print I, comma values I. Okay, the third version is where we don't use index values at all. We just traverse through the list elements themselves, and we go for element in values, print element. And that just takes the 0th element, the first element, and loops over the elements themselves, rather than having this kind of loop counter I, which is going through the indexes. Okay. I typically find myself using this one more than this one, but that's just my habit rather than necessarily it being better practice. Okay, both of these are perfectly valid. This one is potentially easier to understand. You don't have to have that extra index variable that's counting through. Okay, so the next thing to kind of think about with lists is how they're stored in memory, and how what the list variable and calling the list variable is actually doing. So making sure you see the difference between the list variable and the list contents. Now, this is a little bit more complex. We don't necessarily, through the course, we haven't necessarily been thinking about how things are stored in memory, but hopefully this isn't so bad. So the list variable, the name for the list, values, right, is this thing here, right? And it contains a reference to the actual contents of the list. It doesn't contain the list elements themselves, it contains a reference to the memory locations where all of the contents of the list actually are held. So kind of like in this diagram, in scores, there is a reference, and that reference is pointing to these memory locations. The memory locations which actually hold the contents of that list, in this case, 0, 9, 7, 4, and 5. Okay, so the list variable contains a reference to the list contents. The reference is a location of the list contents in memory. It is kind of a pointer to the memory locations where you can find all of the information, or where all the information is actually being held. Why is this important? Well, when you copy a list variable into another variable, both of your variables refer to the same list. Okay? So previously, maybe we thought about a variable which holds the number 10, and then we have a second variable which we define as the original variable, and then maybe we edit the second variable. That's fine, and it doesn't actually do anything to the first variable because we've made a copy of it. With lists, when you copy a list variable into another variable, you have just a reference to the same list. The second variable is an alias for the first because both variables are actually just referencing the same list. You haven't copied the contents of the list, you've copied the reference to the memory location of the original list. So here we've got scores equals 10, 9, the list containing the elements 10, 9, 7, 4, and 5. Okay, so scores holds a reference to the memory location holding the data 10, 9, 7, 4, and 5. If we declare a new variable called values and assign it scores, we actually assign it the reference to this list. We don't create a copy of this list in memory and put it in a values, or give it a reference to the values, or give values a reference to that new list. We haven't copied this list at all. We've copied the reference to that list. So now both scores and values give you the same reference, or have the same reference, so lead you to the same list, that same contents in memory. Okay, so a list variable specifies the location of a list. Copying the reference yields a second reference to the same list. And what then happens is if you modify either of the list through either of the variables, it actually changes for both of the lists, because the lists, when you call the name of the variable for the list, is just calling the reference, so it's just pointing to the memory location. If you change something via that reference, you change the data in the memory location, and then because both of the variables are referencing the same list, it changes in both. Okay, so that's maybe a bit confusing, but if we look at maybe this initially, our list contents when we've declared scores is 10, 9, 7, 4, and 5. 10, 9, 7, 4, and 5. That's what it looks like in memory, and there's a reference from scores to that memory location. We then change the value in the third index for scores to 10. Right? So we go in here, we follow this line, this reference, we go to the position index 3, and we change the 4 to a 10. Okay. Then we print out the element held in index 3 of the values list. Well, what's actually held in the values variable is a reference to the original list, and we go to that memory location and oh look, the position 3 index has already changed. Because we changed the value stored in the memory location, and both scores and values are referencing the same list. Okay, that is quite a contrived thing to explain, but essentially, it's coming from here. When you copy a list variable into another variable, you're just copying the list reference, so the pointer to where it exists in memory. You're not creating a new separate memory location with all of the data copied over. So if you change the original list, because both of the variables are referencing the same list, you will change what happens when you call either variable. Okay. That was quite confusing. I would definitely suggest pausing the video and going through that, because this works differently to how we've looked at all other variables so far. In fact, in the last video, I talked about something called pass by value versus pass by reference. This is kind of what would happen if it's got a similarity to the idea of pass by reference versus pass by value. When we're used to pass by value, we're used to declaring variables that aren't things like lists. So yeah, definitely pause the video, go through this a couple of times. Maybe open your computer, open up Python, type these sorts of things out, and just see that it holds true. That if you edit the list via scores, the value still changes when you call the values list. And then we'll move on to the next section. Okay, so the next section is all about list operations. We're going to look at appending elements to lists, inserting elements in lists, finding elements in lists, removing elements in lists, concatenation, so joining things together, equality/inequality testing of lists, summing through lists, finding the maximum in a list, the minimum in a list, and sorting a list, as well as copying lists in a different way to copying the reference, but actually copying all of the data from the list. Okay, so first of all, appending elements to a list. Sometimes we don't know the values that will be contained in the list when it's created. Okay, we don't know all of the data that's going to be coming into our system. We can't say, we can't pre-fill out our list with all the information. What we then do in this situation is we create an empty list and we add elements to our list whenever we need to. So every time there's a new element that comes in, we just add it to our list. So we start with an empty list, friends equals open square brackets, close square brackets. This creates an empty list, a list with nothing in it. And then as we need to add stuff to it, we use this dot append method. Okay, so friends dot append Harry appends Harry to our list. So our list was empty, and now in the 0th position, we have the information Harry. Okay, and then we can keep appending things. So we can append Emily, so then in the 1th position, or index 1, we have Emily. Then we append again the data Bob. So the element Bob gets put in, gets appended to the list. So that's in index 2, and then maybe we append the data Carrie. That gets appended to the list, so that's in index 3. Okay, so sometimes instead of appending something, so putting it at the bottom, sometimes we need to put things in specific places. Okay, so in specific locations. So sometimes the order in which elements are going to be added to the list is important. A new element has to be inserted at a specific position in the list, and to do that, we can use the insert method. Okay, so instead of using the append method, which puts it at the bottom of the list, or the end of the list, I say bottom because I'm thinking of a memory locations looking like this, vertically, but if we're thinking about it kind of left to right, it would be the far right side, the end of the list. That would be via the append method, but what happens if we want to put it in a specific location? We can use the insert method. So let's say we had a list called friends with the data Harry, Emily, Bob, and Carrie, and we wanted to insert something in the index 1 position. So we have friends, so the name of the list, dot insert, the method name, the position we want our new piece of data to go into, and the data that we're inserting. So insert into index 1 the data Cindy. Okay, Cindy goes into index 1, and then what was in index 1 gets moved into index 2, what was in index 2 gets moved into index 3, what was in index 3 gets moved into index 4, and so on. Okay, so Harry stays where he is, Cindy comes in at position 1, Emily gets moved to position 2, Bob gets moved to position 3, and Carrie gets moved to position 4. Okay, so the new element was added at index 1, elements at indexes 1 to 3 moved to create a slot at index 1. Okay, so we can insert things into our list rather than appending them to the end of the list. Sometimes you have a list of data and you want to know whether or not an element is present in the list. So let's say you had, an empty list and a bunch of data got appended to it, and then you wanted to check whether or not something was in there. You can use the in operator to check whether or not something is in the list. And it will return true if it's in the list, or false if it's not in the list. So if the data Cindy is in friends, so it runs through the list friends and checks each index to see if the data Cindy is in the list. If that returns true, print she's a friend. If it returns false, it would move on to the next line of code. Sometimes we don't just want to know whether or not there is an element in the list, okay, whether or not Cindy is a friend, but we want to know in which position that element occurs. So the way we can do that is using the index method. So the index method will tell us what index yields the first match with the data we're looking for. So if we have the list friends equals Harry, Emily, Bob, Carrie, and Emily, n equals friends.index Emily, so we've got a variable called n, go through the list friends and return the first index at which the data Emily appears. Okay, Emily appears at the position 1 index, so it returns 1, so n equals 1. Even though Emily also appears at the index position 4. Okay, so it just returns the first instance. Similarly with this in operator, if Cindy appeared multiple times in the list, well then the data Cindy appears in the list, and so this is true. So this one will just return true or false if the data is in the list. It doesn't matter how many times it's in the list. The index method will return the index of the first match, even if there are multiple matches, just the first one. Okay. So now we've talked about adding things to the end of the list, adding things wherever we want in the list, checking if something's in the list, finding which position it's in the list. Maybe we have found something in the list and then we want to remove it. So the pop method removes the element at the given position. So let's say we had the list Harry, Cindy, Emily, Bob, Carrie, and Bill, and friends.pop1 is going to remove the data from index 1. Okay, so it's going to remove Cindy. Okay, all of the elements following the removed element are moved up one position to close the gap. So it's covered up by the document, but we've got Harry, Cindy, Emily, Bob, Carrie, Bill in memory. We pop out Cindy, which leaves us with Harry, and then we close the gap, Emily, Bob, Carrie, and Bill. So Emily, Bob, Carrie, and Bill all move up one index position. Okay, Emily, after this pop function, is no longer in index 2, it's now in index 1. So the pop function, the pop method is going to reduce the size of our list by 1. Okay, so we've got adding stuff, finding stuff, removing stuff. Concatenation allows us to join lists together. So the concatenation of two lists is a new list that contains the elements of the first list, followed by the elements of the second. So let's say we have my friends being Fritz and Cindy, your friends being Lee, Pat, and Fong. Then we can concatenate them together using the addition operator, or the plus sign operator, the concatenation operator. Our friends are equals, so a new list equals my friends and your friends, concatenated with your friends, which sets up our friends to be the list containing Fritz, Cindy, Lee, Pat, and Fong. Okay, so we've joined the two lists together to create a new list with now 1, 2, 3, 4, 5 elements. Okay, so we can join lists together. What happens if we want to test whether or not two lists are the same? So just like we can test equality in other cases, we use the double equals operator to compare whether two lists have the same elements in the same order. So it's not enough for them to have the same elements, they have to be in the same order. Okay, so the list 1, 4, 9 and 1, 4, 9 are identical. Okay, they are equal. This would return true, but the list 1, 4, 9 is not the same as the list 4, 1, 9. Okay, it's not enough to have the same elements, the elements have to be in the same order. Instead of maybe testing for equality, we can test for inequality using the exclamation mark equals operator, and that does the opposite. Okay, you've seen using double equals for comparison and exclamation equals for inequality testing when we've looked at other variables. Okay, so one of the things that we maybe looked at in, I think it was maybe 2 or 3 sessions ago, is we looked at using loops to sum things up, find the maximum using a loop, finding the minimum of a loop. Well, we can also find the maximum, minimum, and sum things up in lists using functions. So if you have a list of numbers, the sum function yields the sum of all of the values in the list. So sum of the list 1, 4, 9, 16 adds all of the numbers of the list together, so 1 plus 4 plus 9 plus 16, and returns the answer, returns the sum of the values. In this case, it would return 30. For a list of numbers, the max and min functions return the largest and smallest value. So the maximum function takes the list, for example here, 1, 16, 9, 4, and returns 16. The min function, taking the list Fred, Anne, and Sue, would return Anne. That's minimum in lexicographical, I think is how you say it, order. Lexicograph. Yeah, I'm not going to be able to say that word, but hopefully you know what I mean. Another method that we can use is sorting. So sometimes we get some data in and it's just appearing in a random order and we want to sort it into ascending order or descending order. We use a sort method to do that. So let's say we had values equals the list 1, 16, 9, 4. Values.sort is going to sort that list, and now it's in ascending order. So 1, 4, 9, 16. Okay, so earlier on, we talked about the fact that when we copy a list variable, we do not copy the elements of the list, we copy the reference to the list. Okay, so as discussed, list variables do not themselves hold list elements, they hold a reference to the actual list. If you copy the reference, you get another reference to the same list. So if you were to change values, you would change something in the memory locations that values reference. It just so happens that prices also reference those same memory locations, so it would change for prices as well. Sometimes you don't want that. You want to make a copy of the list in memory. That is a completely new list that just has the same elements in the same order as the original list. To do that, you use the list function. So you have a new list, which we're going to give the variable name prices, equals list, so the name of the function, and then the list that you want to copy, so values. Okay, what this is then going to do, instead of having prices having a reference to the same memory location as values, we have now 2 different memory locations, values referencing one memory location with all of the data for that list, and prices referencing a completely separate set of memory locations with a copy of the original data. So just to quickly recap the common list functions and operators that we've looked at so far, we have the square brackets operator, which is used to create a new either empty list, which is just square brackets with nothing in them, or a list containing initial elements. So open square bracket, element 1, comma, element 2, comma, dot, 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 and eventually close square brackets. We looked at the len function, which takes a list and returns the number of elements in the list. List sequence, which creates a brand new list containing all the elements of the previous, or the sequence that's provided to it. This is used for copying the entire list rather than copying a reference to the original list. Values times num will create a new list by replicating the elements in values num times. So if you had a list with 2 elements in it, and you could repeat that list 3 times if you wanted to, brand new list, with the original list multiplied 3 times, so repeat it 3 times. Values plus more values is concatenating lists, so creating a new list by concatenating elements in both lists together. Okay. Then we have a list, open square brackets. You can either provide a single element to access a single index to access a specific index, or you can use the idea that we looked at when we talked about strings with from : 2. So this creates a sublist from a sequence from a subsequence of elements in the original list L, starting from position from and going up to, but not including the to position. Okay, both from and to are optional. Then we have the sum function. Sum L returns the sum of the values in the list L. Min L and max L return the minimum and maximum values in the list L. L1 equals L2 does a comparison of the two lists. They are equal if they have the same elements in the exact same order, otherwise they are not equal. And then we have some common methods that we might use on lists. So L.pop, if L.pop without a argument provided to it just pops the last element from the list, or L.pop position removes the element from a specific index of the original list. All of the elements following the given position are moved up one place. Okay, so if you remove the element at position 1, the elements in index 2, 3, 4, and so on are going to be moved up one index place. The insert method, you insert into a specific position an element, some data. So you insert the element here at the given position in the list. All elements at and following the given position are shifted down. So if you inserted into position 1, the current element in position 1 gets shifted to position 2, the element in position 2 gets shifted to position 3, and so on. L.append element, so the append method appends the element to the end of the list. The index method returns the position of the given element in the list. The element must be in the list for it to return the position that it exists in the list. It returns the first instance of that element in the list. If there are multiple instances, it returns the index of the first one it encounters. L.remove element, so the remove method removes the given element from the list and moves all elements following it up one position. Again, it removes the first instance it encounters of that element, not all. Not all. The sort method sorts the elements in the list from largest to smallest. From smallest to largest. It sorts them into ascending order. Okay, so that's kind of a list of common methods that you might use, as well as some common functions that you might use and operators. The other thing that we looked at when we talked about strings that we might want to do with lists is slicing up a list. Sometimes you only want to look at part of a list. The argument for the slice operator are the first index to include in the slice followed by the first index to exclude. So for example, you're interested in the temperatures only for the third quarter with index values 6, 7, and 8. So you imagine you've got January, February, March, April, May, June, July, August, September, October, November, December. Okay, we only want them from 6 up to, but not including 9. Okay, because we want 6, 7, and 8. So second quarter equals temperatures 6, 2, but not including 9. Okay, slices work with all sequences, so this also is how we do it with strings, which you have seen previously. A couple of common list algorithms that you might be using when you're using lists. You might be filling out a list, you might be combining out list elements, maximum and minimum, collecting and counting matches, removing matches, swapping elements, reading input. So we're going to go through each of these individually. Okay, so filling a list. This loop creates and fills a list with squares, so 0, 1, 4, 9, 16. So we define the empty list, right? Values equals empty list. And then for I in range n, so as many elements as we want, values.append I times I. So initially I is 0, so we append 0 times 0, which is 0. So our empty list now contains in index 0 the value 0. Then I is incremented, so I is 1. We get 1 times 1 is 1, so we append the value 1 to our list. Our list currently contains the value 0, so in the index 1 position, we put the value 1. Then I increment, so I is now 2. 2 times 2 is 4, and then we append that value 4 to our list. So our list now contains 0, 1, and in the index 2 position, we have the value 4, and so on. Okay, so we're filling out our list, in this example, with squares, 0, 1, 4, 9, 16, and so on. Combining list elements, so if we didn't want to use the sum function that we've seen before, it was a function that was described previously, we could do it manually using a for loop, so result equals 0. For element in values, so looping through the elements in the values list, result equals result plus element. Okay, so initially we have 0 plus something, and then that gets substituted in a result, and then we go on to the next element in values and we add that on, and so on and so on. This will sum up all the values in the values list. To concatenate strings, you only need to change the initial value. So instead of having our initial value for result being 0 and we're summing up numbers, to concatenate a bunch of strings, our initial string is just going to be the empty string. Okay, and then result equals result plus element, so element in names. Again, initially we have the empty string plus concatenated with something. We store that in result, and then we loop through and repeatedly concatenate the next element on from our list called names. Maximum and minimum, we looked at this in a previous session, looking at using a for loop to do this with just variables. This one we're going to do specifically with a list. So finding the maximum value from a list rather than the maximum value from a sequence of values. So largest equals values 0. So the first value in our list, because if it's the only one we've looked at so far, then it's going to be the maximum value. And then we slowly go through the list for I in range 1 up to the length of the list. If the value at the current index is bigger than our current largest value, update our largest value to be the value at the current index in our list. Okay, so initially, let's say our list is 1, 5, 10. Largest is initially set to 1, and then we look at the next element, which is 5. 5 is bigger than 1, so 5 is now our base element, and we check the next element in our list, which is 10. 10 is bigger than 5, so 10 becomes the value stored in our largest variable. Okay, minimum, very, very similar, apart from instead of having largest, you'd use smallest, and you change how you're doing the comparison. Okay. Let's say you have a list and you want to you're collecting matches from a list. So for element in values, if element is greater than limit, result.append element. So let's say we're trying to collect all of the incidences of people scoring 100 or more on, let's say, an IQ test. We run through our list of IQ tests. If the IQ test score is greater than 100, append that to our new result list. Okay. So we have a list here called result, which is set up to collect all of the incidences where people do better than some indication, right? So here, better than 100, greater than 100. And we're using the append method. If we wanted to, instead of collecting these matches, count the number of matches, we have a counter equals 0, for element in value, so go through the list. If element is greater than limit, just increment the counter. So this is going to return all of the scores that are greater than 100 in a list. This is going to eventually pop out with a counter variable, which has the number of times someone's done better than 100. Okay. Sometimes you might want to remove elements that match a particular condition. So this one, we're grabbing them and we're putting them into a new list. Maybe we want to take our initial list and remove them. So remove all strings of length less than 4 from a list. So I equals 0, while I is less than the length of words. So go through our list of words. Our current word that we're looking at is the index I of words, the ith element of the list words. If the length of that word is less than 4, remove the ith element from the list. Pop that one out. Otherwise, just increment our loop counter and go back to the start. Okay, so we look at the first element. If it's too small, we get rid of it, and we look at the next element. If it's too small, we get rid of it. It's important here that this increment only happens in the else condition, because if we pop something out, remember that everything in the list shifts up a place, so we're not actually going to end up getting stuck and looking at the same thing or skipping over certain elements. If this happened every time, we would skip over an element every time we removed something. Okay, sometimes we might want to swap elements. For example, you can sort a list by repeatedly swapping elements that are not in order. Swap the elements at positions I and j of a list of values, right? We've got something in position I, we want to switch it to position j, and we want the element in position j to take the place of position I. We'd like to set values I to values j, but that then overwrites the value currently stored in values I, and we need to put that at some point in values j. So we need to save it first. So this kind of picture in the bottom left-hand corner kind of explains that. Before moving a new value into the location, say the blue location, we copy blue's value into a temporary location, then move black's value into the blue location, and then move the temporary value into the black location. Okay, we need this temporary value to kind of allow us to swap the two elements around. Okay, so let's say we want to swap the element in position index 1 and the element in index 3. Okay, so this is sets up the scenario for the actual code that we're going to follow. So we have a list called values, which has a reference to the values 32, 54, 67.5, 29, and 34.5. Step 1 is actually setting up our list. Okay, so then this step 2 is to create our temporary value, right? This is to create our kind of blue outline space, our temporary value to store data. So we have temp equals values I. So we're storing the information temporarily in index I, so we're storing temporarily 54. Step 3 is then to update the value in index I with the value in index j. So we put 29, which is from index j, into index I. And then we take our temporary value and slot it into values j. Okay. So to do this, we had to kind of, if we remember, like, look at this image, you take the blue shoes and you put them in a temporary location, you put the black shoes where the blue shoes were, and then you put the temporary location, which were the blue shoes, into where the black shoes were. Okay, so that's what this temporary value is doing. It's temporarily holding some information for us, or this temp variable is temporarily holding some information for us to allow us to do the swap. Moving on, it's very common to read input from a user and store it in a list for later processing. So we start off with an empty list. Please enter values and then Q to quit. The user provides some input. While the user's input isn't a uppercase Q because they want to quit, we append that data into our values list, right? And then again we get them to enter more data, and then we check, hey, is that data a capital Q? If it's not, put this new data into our list, and then get them to enter something new. Okay, so the program execution will print this please enter values or Q to quit. We enter 32, we enter 29, we enter 67. When we enter Q, it stops the program. Our actual list is only going to hold the values 32, 29, and 67.5. This Q value doesn't get added to our list, right? Because the Q value gets added at this point, and then we check the condition. It never hits this append whilst the user input is the Q value. Okay, a function, so we looked at functions in the last 2 sessions, can accept a list as an argument. The following function, defined here, visits the list elements but does not modify them. So def some values, total equals 0. For element in values, total equals total plus element, return total. So it goes through the list called values, takes each element, adds it to a total variable, and then returns that total. At no point here are we editing the values list. However, we can edit or modify the list values, the elements in the list in a function. So def multiply values comma factor for I in range len values values I equals values I times factor. So we multiply each element in our list. So for I equals 0 up to the length of the list minus 1, we take that element from the list, we multiply it by our factor, and then we store that in our original list. Okay, so as an example, the parameter variables, values, and factor are created. So scores has a reference to the list in memory. Values is a variable, and so is factor. Okay, the parameter variables are then initialized with the arguments that are passed to the call. We're passing the scores variable to our that's the argument that we're passing into our function call. Remember that when we do this with lists, we don't create a copy of the list, we create a copy of the reference to the list. So values now holds a reference to that memory location, the original memory location. It does not hold a reference to a brand new copy of the data. Okay, and then factor equals 10. So in our case, values is set to scores and factor is set to 10. Note the values and scores are references to the same list. So then when we do the multiplication, we're changing the data in values. So we follow the reference, we take 32, we multiply it by 10, which is 320, and then we update the value in the values list. So we follow the reference and we update the value. So it's now 320. We repeat for 54, 67.5, 29, and 335. So this produces 320, 540, 675, 290, 350. Okay. The function returns. Its parameter variables are removed, so we get rid of values and factor. However, the score still refers to the list with the modified elements because values and scores contained a reference to a list in memory location, and it was the same. It was a reference to the same list. Okay, so that's quite dangerous, especially when in the last session I was talking all about the idea of pass by value versus pass by reference. If you're using a function with lists, you are passing by reference typically, unless you use the list function we talked about earlier, and as a result you will be modifying the original list, not doing something with a copy. Okay. Sometimes you might want to return lists from a function, so simply build up the result in the function and return it. In this example, the squares function returns a list of squares from 0 squared up to n-1 squared. So we want to return a list from our function. We have squares n, it takes some integer value n, creates an empty list for I in range n, so up to the value that we've just been given, result.append I times I. Okay, and we looked at this one earlier, and this just builds up a list of squares, and then this list gets that value appended to it, so slowly this list grows and grows and grows, and then eventually we return this result list back to wherever we called the squares function. Okay, so this goes back to this kind of problem here goes back to the idea of call by value versus call by reference. Call by value, when the contents of a variable that was passed to the function can never be changed by that function. Okay, we pass the value, not the reference to the memory location that the original value was held. Call by reference, pass by reference, the function can change the arguments of the method call. A Python method can mutate the contents of a list when it receives a reference to it, which is this issue we have here. Okay, so that's kind of maybe we're reaching the end-ish of lists. There's like one or two more things that we need to talk about a list, but we're going to introduce a new data type right at the very end called tuples. So a tuple is quite similar to a list. However, once it's created, its contents cannot be modified. It is immutable. Okay, so it's an immutable version of a list. A tuple is created by specifying its contents as a comma-separated sequence. You can enclose the sequence in parentheses. So triple equals, open parentheses, 5, 10, 15. Triple is now a tuple. It is immutable. These values, this contents cannot be modified. If you prefer, you can omit the parentheses. You don't have to have a parenthesis to open and close a tuple. I typically would have them. I think this line is far clearer than this line, but that is personal preference. So why would tuples be useful? Well, sometimes we want to return multiple values in a function. So it's common practice in Python to use tuples for that purpose, to return multiple values from a function. So we have a function called readDate, which enters a date, enter a month. Sorry, it prints out enter a date, then it asks the user to give them the month, the day, the year, and then it returns to the user the tuple month, day, year. Okay. We have the function call here, which actually gets us into the function date equals readDate. And we could use so that would assign the entire tuple month, day, year to date. Or we could use a tuple assignment, which would have a tuple month, day, year equals readDate, and that would return month, day, year. Month would be assigned to month, day would be assigned to day, year would be assigned to year. Okay. So in this case, date is the tuple month, day, year. In this case, we have month, day, and year assigned to month, day, and year. Kind of wish that these were labeled slightly differently because I think that would make it slightly clearer. Okay, so moving on from tuples, sometimes we want to store things in tables, kind of like a spreadsheet, right? 2 dimensions. We want some rows and we want some columns. This is sometimes known as a matrix. That has a meaning in maths. For computer science, we're going to be, or at least this course, we're going to be thinking of them as rows and columns. So if we look at this kind of figure skating count, we have the rows. So we have a row here, a row here, a row here, and so on. And we also have columns. We have a column for the names. We have a column for the golds. We have a column for the silvers, a column for the bronzes. Okay. Here is the code for creating a table that contains those 7 rows and those 3 columns, which is suitable for holding the medal count data. So we're only thinking about this internal bit of numbers here. We're not necessarily thinking about the titles. Okay, so countries equals 7, so we're saying that we've got 7 countries competing. Medals equals 3, we have 3 columns for medals, gold, silver, and bronze. And then our actual table is a row which has 101 in it, 101. A row which has 111, 110 in it, 110. A row that has 001 in it, 001, and so on. 100, 100, blah, 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 blah. Okay, so this first square bracket opens up the list, and that closes the list. The first element in the list is a new list, which has the elements 1, 0, 1 in it. The second element in our list is a list containing the elements 1, 1, 0, and so on. Okay, so what this does is it creates a list in which the elements in it is itself another list. So it has a reference to a list, which is full of references to other lists, which have data in them. 101, 110, 001, 100, 011, 011, 110. Okay. Sometimes you will need to create a table with a size that is too large to initialize with literal values, right? Writing this out is kind of annoying. Maybe we want to create a table in a much larger table much more quickly that I'm not going to go through and I'm not going to type out all the data into straight away. I'd like to be able to do it in a faster manner. So the first thing we do is we create a list that's going to be able to store the individual rows. So table equals the empty list. Okay, then we create a new list using replication with the number of columns as a size for each row in the table and append it to the list of rows. Okay, so our table is going to hold rows, and each element is going to be filled up with an individual row. So we're going to have 5 rows, and each row is going to have 20 columns. So for I in range rows, row equals 0 times columns. So this is going to produce a list called row with 20 zeros in it. So it's going to open the list 0, 0, 0, 0, blah, 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 20 times. And then it's going to append that row to the table. So the first element in our list table is a list containing 20 zeros. And then we increment the I, and repeat this process. So our second row is going to be a list of zeros, 20 of them. We're going to append that, and then we're going to do this 3 times, 4 times, 5 times. Okay, so by using this kind of replication, I don't actually have to type out all of these zeros and put all of these commas in. I can just do it with a quick Python script. So the result is a table that consists of 5 rows with 20 columns. Okay, how do we access elements from a 2-dimensional list? We do it by row, then by column. So medal count equals counts, row, column. So we're going to go to the third row. Oh, sorry, we're going to go to the index 3 row and the index 1 column. So index 3 row and index 1 column. Okay, to print, use nested for loops. Outer row is I, inner row is j. So this is us printing stuff out. For I in range countries, so for the number of countries we have, so each country gets its own row, we're going to go through the medals columns and print out the number of medals that country has. So print %d, counts ij, so the ith row, the jth column, and then we're going to have an end equals empty string to stop Python printing a new row, a new line, sorry, to the shell. So this accesses the ith row, the jth column, and prints out that value, does that for the entire row, then prints out a new line, and then we start again at the next row down. Okay, so that's quite an interesting thing to do. Maybe take a pause, create your own medal table, try and print out your medal table. But yeah, the first element is the row, the second index, sorry, is the column. Other part of using these i's and j's and getting used to thinking about columns and rows and indexing things is some programs work with 2-dimensional lists, and those 2-dimensional lists need to be able to access the elements that are adjacent to them, adjacent to something that you're thinking about. It's particularly common in games. You are at location ij, so you're in the ith row, the jth column. What are the locations adjacent to you? Well, 1 row up in the same column, 1 row down in the same column, the same column but 1 column to the left, sorry, the same row but 1 column to the left, the same row but 1 column to the right, and then also diagonally. So 1 row up and 1 column to the left, 1 row down and 1 column to the left, as well as 1 row up and 1 column to the right, and 1 row down and 1 column to the right. The only thing that then you need to be careful about is making sure that you don't go off the board, right? This idea of the board not going outside your specified table, for example. Making sure you don't go too high, so you're accessing a value that isn't in the list, or going too low and trying to access something that's also not in the list. Okay, so let's say we want to add up the number of medals a specific country got. So for j in range medals, okay, so this is going through the columns, total equals total plus counts ij. So we fix our row at I, and we add up the number of golds they have, the number of silvers they have, and the number of bronzes they have. They get added together. This is what this set of code is doing. It's adding up a row of values. This set of code here, total equals 0 for I in range medals, total equals total plus counts I, is adding up, this shouldn't say medals, this should say countries, is adding up the number of silvers that were given out, right? Or the number of bronzes that were given out, or the number of golds that were given out. We're fixing the column and adding up all of the entries for the rows. Okay, so fixing I and going through j fixes the row and adds up the values for those columns. Fixing j and running through I adds up all of the rows for a specific column. Sometimes you will be passing a table to a function. When you pass a table to a function, you will want to recover the dimensions of the table. If values is our table, then len values is the number of rows. Okay, if we look at this here, len values, well, this is 1 value, 2 values, 3 values, 4, 5, 6, 7. So the length of counts is 7. It has 7 elements. Okay, so that's to work out the number of rows. Len value 0, so we go into our first list, our first element, which happens to be a list. We find out the length of that list. That gives us the number of columns. Okay, so for example, the following function computes the sum of all elements in a table. So we pass the function sum a table. We have total equals 0. For I in range len values, so for the number of rows, for the number of columns, total equals values ij. So I gets set to 0, j, so we're at the 0th row. We add up all the values in the 0th row to our total variable, and then we move down to the next row and start again. Through all the columns, move down to the next row, start again through all the columns, keep adding everything up. Eventually we reach the bottom of the table and we return that total. Okay, it's probably worth drawing a table and kind of putting your paper clips there, one for I, one for j, and moving the paper clips through as you run through this piece of code by hand. Okay, so here is a full Python program for that original metals table. So metals equals 3, there's a gold, a silver, and a bronze. Countries equals 7, there are 7 countries. We're going to create a list of all the country names, so Canada, China, Germany, Korea, Japan, Russia, and the United States. We're going to create a table of the metal counts. So this is our first row, which is 1, 0, 1, and all the way through. Row 1, row 2, row 3, row 4, row 5, row 6, row 7. We're going to print a table. It's going to have an empty space, then country, gold, silver, bronze, and total. Okay, so basically a table header for the country that we're talking about, how many golds they won, how many silvers they won, how many bronzes they won, how many medals in total they won. So then we're going to print something out, print countries, counts, rows, and row totals. So for I in range countries, so for the number of countries that there are, print to 15 characters the ith entry of the country's list. So that's going to print out it's going to print out Canada, then it's going to print out Canada, then Germany, Canada, China, Germany, Korea, Japan, Russia, United States, on each full loop through this for loop. Okay, so the first thing it does is it prints out Canada, then it moves on to the next thing, so print each row element and update the row total, so total equals 0. For j in range medal, so we're fixing the row here, we're adding up the total for that row. So for Canada's row, we're going to print out 1, because it got 1 gold, no silvers, 1 bronze. That gets our total to 2, and then we print out our total. That's 1 full loop through our program. So we finish with our Canada row, we'll move on to the next row, which is our China row. So we print out China, we loop through China's rows, printing out the number of golds it gets, printing out the number of silvers it gets, printing out the number of bronzes it gets. Whilst we're doing that, we're keeping track of the total number of medals they've won, and finally we print out the number of medals they won. So that kind of brings us to the end of lists. It's quite a long one. Obviously, this video is far longer than any of the other ones we've done. So a quick summary recap of lists, and then that's kind of it until you try and do the final problem sheet, and we are finished with the course. So a list is a container that stores a sequence of values. Each individual element in the list is accessed by an integer index I, using the notation list square bracket I. A list index must be at least 0 and less than the number of elements in the list. An out of range error occurs if you supply an invalid list index. It can cause your program to terminate, and it will throw an error code. You can iterate over the index values, or you can iterate directly over the elements of a list. A list reference specifies the location of a list. Copying the reference yields a second reference to the same list. Be careful, you're copying the reference, not copying the entire list. A linear search inspects elements in a sequence until a match is found. You need to use a temporary value when swapping elements around in a list. Okay, go back to the shoes thing and the temporary blue shoe location. Lists can occur as function parameters, and they can be returned values as well. When calling a function with a list argument, the function receives a list reference, not the copy of the list. We are doing pass by reference here, not pass by value. Be careful, you will change the original list. A tuple is created as a comma-separated sequence enclosed in parentheses. Tuples are immutable. Okay, you cannot change the values, modify the values once it's been created. By combining fundamental algorithms, you can solve lots and lots of complex programming tasks. You need to be familiar with the implementation of fundamental algorithms so that you can adapt them. This is kind of going back to the counting, finding the maximums and minimums and things like that. Keeping with lists, you can use a two-dimensional list to store data in almost like a table or a spreadsheet that you might be familiar with, kind of like in Excel. Individual elements in a two-dimensional list are accessed by two index values, one for the row, one for the column. Lots and lots of built-in operations for lists. So the insert method inserts a new element to any position in the list. The in operator tests whether or not an element is in the list. The pop method removes an element from any position in the list. The remove method removes a specific element from the list by looking for that element value rather than that element index location. Two lists can be concatenated using the plus operator. If you don't want to copy the reference of a list but want to copy the actual contents into a brand new list, use the list function. You can slice up lists, so using the slice operator to extract a sublist or a substring. Okay, so the slice operator works on any sequence of values. And that is the end of lists for now. This session is by far the longest. It is by far the most confusing. 2D lists are not pleasant to get your head around because they involve loops within loops and i's and j's. It's not fun. Please take some time and go back through this. Write some stuff out by hand. Try programming some of it on the computer, and hopefully it will all make sense to you. Apart from that, I hope you enjoyed the course. If you have any questions, always feel free to email us at technicamps.com. I've been Luke. Thank you very much.